This question is based upon algebra. We have been given an expression e raised to x plus half x squared minus 2 equal to 0, and the range or interval given is -5 to 5. We need to determine the number of roots this equation would have in this given interval. Now this is not a simple polynomial or quadratic equation which we could manually solve and then check how many values of x satisfy and lie in that interval. That's not feasible in this case because this is a mixed type of function. It is having exponentiation as well as this polynomial term, so we can't do that directly. So instead of solving this equation, let us think about some other way in which we could determine the number of roots directly without actually finding the roots. So one thing that comes to our mind is intermediate value theorem. Just like we have the mean value theorems, this one is intermediate value theorem, which says that, let us say in a given interval, the function is changing its sign. Let us say it was earlier positive and then it became negative. Or if it was earlier negative, then it became positive. Means it is changing its sign in that interval. So if it is changing sign, then definitely at some point it would have become 0. Then only it can change sign from positive to negative or negative to positive. So in the given interval, if our function is changing sign, we would say that it is having a root. But how many roots? That we don't know. Let us say this is an interval and the function is something like this. So it is changing its sign multiple times. So you just checked for once that yes, it is changing its sign once, means it is having root, but you don't know actually exactly how many roots it will have. So for that we need to look at the monotonicity of that function, that if it is increasing or decreasing. Now looking at our function, let us say f of x equal to e raised to x plus x squared by 2 minus 2. Let us check in the interval, let us say -5 to 0. Close to -5, if we substitute -5 exactly, then the value we get is approximately e raised to -5 plus 25 by 2 minus 2. Now this thing will approximately be 0, it would be very less. This is about 12 and a half and then -2. So this thing is definitely positive, right? And if you substitute some lesser value, let us say -1, then for that value it becomes e raised to -1 plus half minus 2. Now this is half and this is again a small thing and we are doing -2. So this has become negative now. So the function has changed its sign, which means it would have had one root, and in the middle we don't see any point at which the function would have changed its monotonicity. It seems to be strictly decreasing in this interval from positive to negative, which means it would have had one root over here. We can also check for 0. The f of 0 becomes e raised to 0 plus 0 by 2 minus 2. This thing is 0, this is 1. So 1 minus 2 minus 1, again this thing is negative. So this function is strictly decreasing from -5 to 0. It would have gone from positive to negative this way. So it has one root in the interval -5 to 0. Now let us check for the interval 0 to 5. For 0 we already saw that it is negative. Let us check for 1. For 1, f of 1 becomes e plus half minus 2. Now this is half and this is e. The value of e is approximately 2.2, about 2.1, greater than 2, and then we are adding something to it and subtracting 2, which means it is positive. So for 1 it is again becoming positive. And similarly for 4 or 5, if you will check, e raised to 4 plus 16 by 2 minus 2, again this thing is positive. So afterwards it is positive. So between 0 to 5 it is again changing from negative to positive, and the function is strictly increasing in this interval. So in this previous part it was monotonically decreasing, and in the next part 0 to 5 it is monotonically increasing, and hence in this interval also it will have exactly one root. So our function is changing its sign only 2 times, one between -5 to 0 and once between 0 to 5. So this function will have exactly 2 roots in the interval -5 to 5. So our answer will be 2. The number of roots this equation has in the given range are 2.